Hello YouTube, Tom Matthews from Matthews Engineering here. I want to show you guys this Hewlett Packard Minicomputer. They probably called it a calculator, but when you see how this thing works, you'll see that it's more than that. A friend of mine who's a retired accountant had this, and he used it in his accounting practice to do complicated calculations, and they even stored some programs to do state forms. I'm going to show you how that works. When he brought it to me, it was in a non-working state, and I have a small HP collection, so he knew I was interested in these, and the more I looked at this, the more I thought it was worth putting some effort into fixing it. Now, I've got a lot of projects going on in the shop, and this is what I call a recreational project, so I wasn't working on this full time, but boy, is it interesting. And it's useful in engineering. It's useful to occasionally do a project like this to see how other people design things, and Hewlett Packard really did some fabulous engineering. This HP9810A calculator is from 1971. Let's take a closer look at this, and I'm going to show you what it took to fix this, and maybe give you some tips if you've got one on how you can fix yours. Let's take a closer look here. Hold on a second. Okay, so it's a desktop unit, and let's go ahead and turn it on. One of the things when you're working on things is you're going to be turning it on and off a lot, so I rigged it up with a little switch box here so that I could turn it on and off whenever I want. I put a little light on there when I'm working on stuff. I like to know if it's on or not because I don't want to get shocked. But so here's this when it's fired up. And of course, when I had this, I had a totally blank display for the longest time. Couldn't figure out what was wrong with this guy. But it's got modes where you can tell it to be, if you want to do money calculations, which my accounting friend probably did it in this mode, where you can set the digits to, 2 spaces, or you can say, make it go back to scientific notation. These were an early incarnation of reverse Polish notation. I'm an HP fan, and I've always loved the HP15C, which I think is the best calculator ever, and it's reverse Polish notation. And so was this, although it's kind of an early incarnation of it, so if you're used to using a more modern RPN, this type is a little confusing, but this had, some pretty advanced features on it for the time, for 1971. It had, pi in a register, so to do a calculation, you'd maybe say 2 times. Well, I'm doing it wrong because it is a little different. So you'd roll the 2 up into the register, bring pi into X, and then say times, and I've got 6.28. And it also had exponent scientific notation, so you could process very large numbers in an amazing machine, which was a serial Minicomputer. And we'll look at the block diagram in here in a second, and we'll see why that's the case. But it had, scientific features like pi, reciprocals, memories where you could store variables. You could put programs into this, square root, exponents, very interesting. And the programs at the time could even control printers and external devices, so a pretty neat machine. And I've really enjoyed looking at it and trying to get it to work. So let's take a quick look at here's the block diagram of this. And you might think, oh, Tom, that's not a Minicomputer because it says microprocessor there. But that's another circuit board. Let's see, that's a VIO board. The microprocessor board is a complete board with the shift registers. Let's see, there it is. So here's the microprocessor board, and you can tell I've been working on it. But it had everything stored in mask ROM with a serial type processor with I think it's a 28-bit. A word would come in with the instructions, and it'd also tell the processor what the next address of the next instruction was, that type of thing. When troubleshooting this, I originally tried to understand how it works, And, from an engineering point of view, that's usually how you do things. You try to understand how it works and then find out what's wrong. And that helped a little bit, but sometimes you have to use other troubleshooting methods. And what I ended up doing is a good friend of mine loaned me these extender cards. I needed a 15 by 2 and an 18 by 2. And then I was able to use these to extend the microprocessor board, the clock board, the I/O board, the shift register board up, high. And then I systematically went along each edge card connector on the front and back and looked for non-TTL signals. So this era had all 74 series logic. It wasn't S logic, it wasn't LS logic, it wasn't HCMOS, it was 74 series. And that's, about 0.2 volts to 4 volts. So about 0.2 volts would be a 0 and 4 volts would be a 1. And I looked at every signal, and I would occasionally find signals that would be just 1 volt or something that just didn't look like a good logic signal. And I would record them over here with red highlighter. And then I troubleshot those. And in almost all cases, they led to TTL ICs. You can see, how much paper you have to get out to fix something like this. These are all the data sheets of the various TTL ICs. And once I found a suspicious signal, because a product like this doesn't have many analog signals in it, so I'm really expecting digital signals. If it really was an analog signal, then I would have looked on the schematic and said, oh, let's not investigate that. But when you find a signal that's 1 volt in a logic assembly that's supposed to be 0 or 4, something's wrong. And so what I did is trace it back to the source IC, get the data sheet for that, probe around that IC, make sure that I'm certain that's the source of the problem, and then replace that IC. Now, I replaced these 74 series ICs in all cases with more modern HCMOS ICs, and as you can tell, they do work. They finally worked. So they're probably the HCMOS output, noise margin is excellent because they drive all the way to the ground and up to +5. So the signal quality on the outputs was excellent, and doesn't cause any harm to the older series logic. The input thresholds are close enough that they're they do work, and they work nicely in here. But as you can see, I had to do a lot of ICs. So the other problems when I was looking for signals that weren't right, 2 things I found was a solder short. Now, I don't know if this has been in here since 1971, or maybe somebody else was working on this. This looks like a blob of solder. Maybe somebody had a test wire there and they didn't clean it up very well, but that was crowbarring off of here. When I cleaned that up, I thought, oh, it's going to be fixed. No, it still wasn't fixed. So I kept working, and then I found another one. This is what made me think somebody was working on this, and maybe a blob of solder fell off of their soldering iron. Cleaned that off, still not fixed. Then I started to find, logic ICs that were dead. And these are the 5 ICs that I had to replace before it started working truly. But every time I would replace one of these, I would get a crummy TTL signal that was restored to what I thought it should be, at least 0 to 4 volts. But with these, when these were replaced with modern HCMOS, I got very good 0 to 5 volt logic signals. And the first one that I did was on the clock board, because of course on a processor, the first thing you want to do is make sure the clock is working, or you make sure the voltage rails are working, then the clock. So these were 7474 flip-flop, a 2 74-155s, a 7408, and a 7432 all had to be replaced. And it wasn't until I replaced those last ICs that it came to life. And boy, it felt like, Frankenstein's monster come to life. It was very exciting. Once I had that working and I could see that it was all good, I started to look, at other things on this. This has, these were options. I think these might have been actually pretty expensive options at the time. It has a printer cartridge. These were ROM cartridges that had microcode in them. and so that would drive a paper tape printer. And since the original owner of this was an accountant, you know, I can imagine that he used the paper tape a lot, and that's a thermal paper tape. It also had an external typewriter option, so he told me the brand of the typewriter. It was not a Selectric, but it was had a giant interface box, and you could run programs. And one of the programs that my friend Gary, the accountant who gave this to me, here's what the programs look like. They run a little magnetic card. One was called State Forms, and so he told me that they had a program. I don't know if it was, you know, like 1099, it's probably something else in the 70s, but they had a program on here where they could load a form in the typewriter and enter the customer's name and the data, and it would fill the form out for them. So that was probably a pretty neat feature in the 1970s. So, but neither the card reader, so these magnetic cards you'd feed through here and it'll motor them through there, neither that nor the printer worked. Let's open this up and take a look in here. I'm going to gently pull this back so you can see behind here. This card reader, the rollers in there were all dried out, and so with the help of the HP Computer Museum website, which has some discussion about this on there, so here's what the rollers look like. They had crumbly yellow stuff on here that I scraped off, and this photo doesn't quite show how bad they looked, but once I cleaned them up, I put 2 O-rings on here, and these are just regular O-rings you can get from McMaster Car. There's the part number if anybody needs to try this themselves. The website that I had that talked about this said to put 3 of them on there, but the center one didn't seem to be helpful, so I just put 2 on, and they seem to work really good, and they pull the card through nicely. So that's card reader is fixed. Here's the card reader in the machine. The thermal printer was quite a bit more of a trouble to get it to work. You can see it's working. I ran a test program, and I've got some newer thermal paper coming that might have a little bit better contrast, but that's probably as good as it was in the 1970s. So the thermal printer down in there has rubber bands that pull the paper forward, and there's also a rubber roller behind the paper here, and let's show you what was wrong with those. So the rubber bands were stretched and loose, and you can't get these parts anymore. So I thought this was hopeless, but I realized that if I could move this entire roller back, I could stretch those and get them to work again. So what I did is I took, this picture doesn't have very good contrast. Here's the original hole. I moved it about a 1/4 inch to the left to tighten these bands up a lot so they can now work properly. And that was one problem with the printer, but a more ghastly problem with the printer was the main feed roller had just dissolved into black goo, and so I had to clean all that goo out of there with alcohol and acetone and take this apart. And then trying to find a roller is very hard, but I found this rubber hose, again McMaster Car, that has a 1/4 inch inner diameter and 5/8 outer diameter. Here's the part number there if anybody needs it there. I think it's 5234K403. And I cut a 2-inch piece, and I put a little bit of bicycle wax on the like cleaning wax. You could probably use car wax to help slide that on there. The nice thing about wax is once it's on there, it'll dry and it'll turn properly. And that worked in getting the printer to work, although it's quite a fright to disassemble this printer. If you're not used to disassembling things that are complicated, you might have, panic. I almost did and almost gave up a couple times, but I finally got it to work. Now the printer also has a bizarre adjustment down here. See these little nuts here? These are like little eccentric nuts that adjust the positioning of the thermal print head. And when I first put this in here, this didn't work at all until I made some adjustments here. It was just mostly trial and error, and I started to get a clean printout. And so I'm delighted to see that that's working. Maybe I can see if I can get that to print something here. Let's see if it will. You can see a couple numbers coming out of there. But a really fun project. The other thing that's wrong with this, before I put it back together, I think I'm going to have it, in ship shape, is the original feet. There were some feet back here, plastic feet, and boy, these just crumbled. When I took them apart, the plastic just crumbled. But so I reverse engineered them. If anybody needs these, I'll send you the file. I reverse engineered a 3D design of those, and I've got 2 of those coming from JLC PCB, printed in their MJF black nylon resin print, so it should be pretty durable, and hopefully those will fit, and then that'll help me restore the back side of that. Anyhow, I hope you're enjoying this as much as I did. These old Hewlett Packard calculators are amazing. This was really a mini computer, and if you look at the schematics of how it's designed, the people who designed this they were ahead of their time, and they were ahead of the early Z80, and people would think, oh, this probably has a 6502 or something in it. No, it was all masked ROM and garden variety logic ICs. Tom Matthews from Matthews Engineering. Hope you enjoyed.